Some of the most hostile landscapes on Earth are also the most effective vaults for human history. For thousands of years, the howling winds and shifting sands have swallowed the physical evidence of entire societies. Looking out across these featureless expanses, the primary challenge is simply finding where to begin. When a settlement is buried under 50 feet of sediment, the top-down view remains entirely uniform. For decades, the prevailing academic view was that these resource-poor regions imposed a strict ceiling on human development. The consensus maintained that harsh climates lacked the carrying capacity for large, settled populations. By applying new survey methods, researchers are documenting complex ruins across global extremes, proving that many of these environments were actually dense hubs of human activity. These arid stretches are massive, intact archives. Archaeologists are only now applying the specific sensor arrays required to document the civilizations within them. Historical records and ancient texts have long hinted at thriving trade networks successfully crossing these seemingly impassable zones. Merchants and travelers routinely documented long-distance journeys linking distant empires. These populations adapted to drastic climate changes by engineering their landscapes. They built reservoirs, diverted water, and constructed infrastructure to master their environments. Yet finding the physical remnants of these hubs proved nearly impossible. To a traditional ground-based survey, the settlements remained virtually invisible. Locating these ghost networks requires a rigorous method for looking straight through the sediment, completely bypassing the reliance on surface-level luck. That transition relies on tools from applied geophysics. Instead of starting with a shovel, today's survey specialists begin with remote sensing hardware. In tropical environments, researchers use airborne LiDAR. A scanner fires millions of laser pulses toward the Earth, penetrating dense vegetation to map the microtopography of the ground below. In places like the Amazon basin and the Mayan lowlands, this technique has revealed tens of thousands of massive, previously unrecorded structures entirely obscured by the canopy. Lasers, however, cannot penetrate solid earth or deep sand. To see into a desert, survey teams rely on ground-penetrating radar, or GPR. This diagram shows how the system operates. GPR sends high-frequency radio waves into the soil. When those waves hit a buried object or a shift in ground density, the signal bounces back. The software translates these signals into a 3D digital model, resulting in a sharp mapping of geometric enclosures resting right beneath the team's feet. By X-raying the Earth, this technology pinpoints exact excavation targets, eliminating decades of trial and error. Once the digital coordinates are locked, the physical work begins. Teams establish strict grid-based perimeters over the anomalies to begin moving the Earth. Extracting centuries of compacted sand is a methodical, manual process. Heavy machinery is risky, so researchers rely on travels to safely expose fragile historical material. Weeks of careful clearing eventually expose distinct architectural features. What appeared as digital static on a monitor becomes physical reality, sprawling civic plazas and towering stone columns. Quarrying, transporting, and carving architecture of this magnitude requires deep societal cooperation and massive organized labor. The physical excavation verifies the remote sensing data. These are the deliberate footprints of a highly structured society. During the clearing of one of these civic complexes, teams often find the physical documentation of that society, such as heavily inscribed stone tablets. To protect its integrity, the artifact is moved to a highly controlled forensic environment. Epigraphists use varied light angles to cast shadows across the faint, worn inscriptions. The text on these tablets provides hard data. The translations describe inventories, taxes, and complex regional economic networks operating out of the exact location where it was found. When researchers combine this economic record with radiocarbon dating from the plaza itself, the function of the site becomes clear. This was an established, permanent civic center, contrasting sharply with assumptions of temporary nomadic outposts. This dispersed settlement pattern perfectly matches the models of low-density urbanism that archaeologists have recently verified in tropical biomes around the world. Ancient populations successfully engineered these extreme climates to sustain large-scale civilization, fundamentally overriding the natural limitations of their harsh environments. massive stretches of the world's most unforgiving landscapes remain completely unmapped, almost certainly concealing similar networks. As remote sensing technology continues to scale, the physical unearthing of these sites will expand our understanding of our own historical capacity for survival.